All right, guys, continuing our review to the normal distribution. Big thing in UT's packet, big thing in our year this year. We've used normal distribution a lot. Just want to give you one last look at it. Make sure you're solid and good with it. Okay, what we do with the most is called the standard normal distribution, and that is when we can use our z-scores, which we did last week. And when that is true, when we're using our z-scores or using the standard normal distribution, our mean is going to be 0 each time. Standard deviation is going to be 1 each time. And when you use your calculator like inverse norm or normal CDF, those are our two big buttons for normal distribution, that's going to be the case. Mean is 0, standard deviation is 1 each time. And this should be a familiar picture with you. We did gestures for this year. The 68, 95, 99.7. 68% of the data is within 1 standard deviation of the mean. Notice the mean is 0, standard deviation is 1. If you go 2 standard deviations away, you're at 95% of the data falls in there. And if you go 3 standard deviations away, almost 100%, 99.7% of the data lies between -3 and +3 standard deviations away from the mean. Those are z-scores on the bottom, by the way. All right. You've also seen pictures like this, and I need you to be a big deal. Like right here's our z-score. Z-score is 2.33, and what that represents is the area past that is only basically 0.99%, less than 1% of the area under the curve is past 2.33. And remember, area also represents probability or proportion or percentages. So like 99.01% of all the area under the curve falls to the left of that z-score 2.33. And we can get those numbers either from a table, which we haven't really done all year, or a calculator or StatCrunch. The calculator is probably a little quicker, which is what I'm going to show you today on the video. So, but you need to get in the habit of drawing those pictures. If you can draw that, and it makes it real. And remember, shade the zone you're looking for, makes it real easy to use your calculator. All right, I'm going to show you 2 examples and we're done. One kind of what I would say going forwards and one's going backwards, depending on what it's asking for. Okay, this first one says, what percent of 14-year-old boys have a blood cholesterol between 170 and 240 mg over DL? And they're going to tell you the mean and standard deviation every time. So what we got to do first, if they tell us that if they haven't standardized it yet, we got to find a z-score. So I found a z-score, which means I'm making the mean 0 and the standard deviation become 1. So because 170 is the mean, the z-score was 0 when I worked it out. 240, I did 240 minus 170 over 30 like we did last week. The z-score is like we did last week, and I got 2.33. All right, now I want to know what percentage lies between those two on the curve. So the curve would look like between 0 and 2.33. The curve would out of 0 here, 2.33 is way over here. So I want that region right there, what that area is. So whenever you're looking for the area, you're going to use normal CDF on your calculator. There it is, normal CDF. You go to stat, no, sorry about that. You go second vars, and you'll see normal CDF. A lower and upper, because, my lower is at 0. My upper is 2.33. I'm choosing those two. Look what it says my mean and standard deviation are. And then you hit paste and you get this number right here. You get 0.4900969464. So what that tells me is 49% of 14-year-olds have blood cholesterol between those two. So 49% have blood cholesterol in that between those two numbers when they're 14 years old. Now, don't forget, if they don't give you both numbers here, like 0 and 2.33, if it goes all the way to the end, we made up numbers like -1,000 or +1,000. You can use whatever you want, but that's kind of what we use during class. Your calculator sometimes will default to something like this, 1E, and you may see that a lot, which is, okay too, if it's using that number. Okay, now let's go the other way. Okay, this one says, scores on the SAT for verbal ability have a mean of 430 with standard deviation of 100. How high must a student score to place in the top 10% of all students taking the ACT? So now we're going backwards. I drew the curve here, and I want to know where the top 10% is. So that's the region right here. What I really need is the z-score. So what I did is this right here. I took my calculator. When you need a z-score, you do inverse norm. Let's see if I can do this. Well, it's not pulling up. But anyway, I'm using this right here, inverse norm. And I did 0.1 on the right. Okay, 10% on the right. I hit paste, and it gave me that right there. It gave me the z-score of 1.28. So that's where that number came from, 1.28. But what I need, that's nice, but what I need is the x value that goes with the 1.28. Okay, so what I'm going to do is I'm going to do the z-score thing backwards. So I did my z-score formula right here, making it equal 1.28 because that's the z-score. What I need to know is what score produces that z-score. So I just left the x there. So what it is, I multiplied both sides by 100, and then I moved the 430 over and got 558. Just solve the equation for x. So it would take a score of 558 to be in the top 10% of everybody taking a SAT. And that's the two kind of problems you're going to see today. One is doing second VARs and going normal CDF. If you know the z-score, you're looking for the area, you do that. Normal CDF tells you the area or the percent. If you know the percent and need the number, you do inverse norm. All right, sounds good. All right, so don't forget our Google Meets on Wednesday. Your homework today will be a Google Doc, so knock that out, turn it into Google Classroom. Your countdown is on, not many more days of stats left. Hang in there, finish strong. Miss you guys. See you soon.